Yes, good morning. Today we'll review the entire first model. It's for the definition of the IoT. This is an IoT things that have unique identity are connected to internet. Generally, you should have a unique identity ID and are connected to the internet. The thing that is a basic definition of the IoT. And I think we have discussed about the characteristics of an IoT: dynamic and self-adapting, self-configurable, interoperable communication protocol, unique identity integrated into the information network. I will not go into these points. Next thing we'll go for that. Now, physical design of IoT things. Physical design of IoT, that is things in IoT. What is meant by things? Things in IoT usually refers to the IoT devices. Things is nothing but an IoT device. IoT device have unique identity. Each IoT device as a unique identity can perform a remote sensing, actuating, and monitoring capability. This basic thing is to need to be. One is called remotely, that is wireless means. It is three things: basic operations. What is called sensing, sensors. Generally, we'll call as an input device, and actuating, it's an output device. The basic thing is for the monitoring. The basic thing is to be monitor that either it is for sensing and actuator, it is for the monitoring the operation. Okay, that is the IoT device. IoT device can exchange data with other connected devices and applications directly or indirectly, or collect data from other devices. The thing is called IoT device. It has to collect a data from the connected device. If you have been connected a one or more than one device in a network, I can exchange the data between the devices and collect from the other device. Data can collect from the other device. It processes the data either locally or send data to centralized server. Collect the data locally or send the data to centralized server. That data, collected data, can be stored in the either cloud. Okay, store the data. That is centralized server. This is a generic block diagram of an IoT device. It's a generic block diagram of IoT device. It consisting of connectivity, processor, memory interface, graphics, storage interface, audio/video interface, IO interface. Okay, IO interface is what is an input-output interface for a sensor or actuators. It is input sensors and output actuators. These are the different set of protocols. One is called UART. UART is the universal asynchronous receiver/transmitter. SPI serial parallel interface. I2C is integrated circuit protocol and can control area network. These are for the communication IO interface purpose protocols. Storage either SDMMC and SDIO. This is a storage interface. Graphically is GPUI and memory interface either NAND/NOT or DDR1, DDR2, DDR3. This is the memory interface. The connectivity either using the USB, universal synchronous bus, host, and RJ45 Ethernet. These are the connectivity. Processor, general processor, any general processor, there is CPU center processor unit, audio video interface. They generally right now all the devices need a audio video interface. Purely in the initial stages, only data can be read and data can be sent. But right now, almost all devices need an audio video interface, and that is for sending data, receiving a audio signal, video signal that requires the audio video interface. This is HDMI and 3.35, 3.5 mm audio and RC video. These are the this is a general block diagram of an IoT device. Consisting of the basic thing is processor with I need internet connection. The physical design of IoT things, that is things in IoT device varied in types. Wearable sensor, smart watches, LED lights, automobiles, and industry machines. Almost all the devices generates data in some form or the other. When the processor by data analyze systems leads to useful information to guide further action locally or remotely. The basic thing is, once you have collected the data, it has to analyze. That analyzed data should be further useful. It should be useful information to guide further action. I have to take action based on the analyzed data. That is locally or the remotely. The basic thing is collect the data. Once you have collected data, it should be analyzed. Once analyzed, that analyzed data should be useful information. From the analyzed data, it should be further guide further action. Based on that, I have to take action. That is either locally or the remotely. Next is IoT protocols. These are the 4 basic layers. I think I have been discussed in the class. One is called the link layer, network layer, transport layer, application layer. Okay, in the link layer, it is nothing but both the data link as well as the physical layer. Okay, link layer consists of the physical layer as well as in the OSI reference model. It has the physical layer as well as the data link layer in the link layer. These are the different protocol set of protocols. It is 802.3 Ethernet, 802.11 Wi-Fi, 802.15.4 LR, WPAR. This low rate wireless personal area network. LRWPAN is the low rate wireless personal area network. 802.16 is the WiMAX, and 2G, 3G, LTE, cellular. These are in the link layer. In the network layer, either it can be IP is the Internet Protocol version 4, IP4, IP6, IP4, and IP6, IP4. The address width of the 32-bit, and IP Internet Protocol version 6, 128-bit address width. Okay, that basic difference. The basic difference between the IP4 and IP6, that address has been increased from the 32-bit address to the 128 address. Okay. Next is LO is a low rate wireless personal area network, 6 LO WPAN. These are in the network layer. In the transport layer, it can be one is connection oriented, second is called the connectionless, one is called the TCP, second is called the UDP. Okay. One is TCP is a connection oriented, UDP is a connectionless service. These are the application layer. In the application layer, HTTP, COAP, WebSocket, MQTT, HMPP, DDS, and AMQP. Okay, I have been discussed these things in the class. We'll go for the next topic. Okay, logic design of IoT. In the logic design of the IoT, basically we will find 3 basic blocks. One is called a IoT functional block. Second is IoT communication models, and IoT communication API, application programming interface. API stands for application program or programming interface. Okay, IoT functional block, IoT communication model. We'll deal with the in detail. We'll go in detail to the communication. I have not covered in the class communication model. We'll go in detail to the communication model. IoT functional block. It consists of the device, communication, service, management, security, and application. The IoT functional block consists of the device, communication, service, management, security, and application. An IoT system comprises of the number of the functional blocks that provides the system the capability for identification, sensing, actuation, communication, and management. In the IoT communication model, basically we have 4 communication models. One is called a request response. First type of the communication model is the request response. Second is the publish and subscribe. Publish and subscribe. Third type is the push-pull exclusive peer. These are the 4 different communication models. These are the 4 different communication models. We'll go for first one, request response communication model. In the request response communication model, client sends a request to server. Client sends a request to server, and once you get a response from the server, the data, the resource can be exchanged from through this server to a client. Okay. That is the request response communication model. In the request response communication model, request response, it is a request response is the communication model in which the client sends a request to server. First, initiation from the start signal, request sent from the server, and server respond to the request. The response is from the server. Request from the, that is a request from the client. Client has to send a request and server has to give a grant, that is a respond. When the server receives a request, it decide how to respond. If it shows the data retained, resources, definitions from the response, then it send a response to the client. Access to response model is the stateless communication model, and each request response pair is independent of the other. The client and the client and the server interaction in the request response model. Only thing is, request from the client and server has to give a grant from that. If it is available the resource, it sends to the based on that request. If it is not there, it is take the data from the resource with the from the server. Store the data from the, it is that receive request from the client, process a request, looks up and fetch a resources from the, it has to fetch a resource from the where the memory, when the data is stored in the memory, that has to be fetched and prepare, respond and send a response to the client. Okay, it is the first send a request to the from the client to the server. From the server, it has to fetch the data, looks up and fetch resources from the available resources and prepare a response and send a response to the client. Okay, it is about the request response. Similarly, next is the publish subscribe communication model. Publish subscribe communication model. In the publish subscribe communication model, here we have the consumer, a client, and a publisher. In between that, one more is there, that is called the broker. One more is the a client, that is a broker. Publisher, it publishes things. Through a broker, it controls the consumers. Okay, here in this publish subscribe is the communication model that involves publisher, broker, and consumer. Here 3 things are there. One is called publisher, second is called broker, third is the consumer. Consumer is a client. Publisher is a publisher information. Publishers are the source of data. He's a source of data. Publisher sends a data to the topic which is managed by the broker. Broker is a manager. In between the consumer and a publisher. In between they are a broker. It manages the topic. What is the publisher? Publisher are not aware of the consumer. Who consumes the data, he is not aware of the publisher. Who is aware? That broker is aware of the knowledge, aware of the who are the consumer, what data have to send. It is an mediator. Consumer subscribes to the topic which are managed by the broker. A mediator, I need to have the data. That data has to subscribe by the consumer to the broker. When the broker receives the data from the topic from the publisher, it sends the data to all the subscriber consumer. Once it receives the data published by the publisher, the broker receives the data. From the broker, it sends the data to the consumers. It is the publish subscribe communication model. In the publisher send a message to the topic. That is message published to the topic 1. Message published by the topic 2. They are the different topics. Topic 1 subscribe. There are different subscribers in the topic who are the request by that particular topic. Here, for example, topic 1 need two consumers. They are subscribers of these two topics. Only those who are subscribed topic are being sent by the broker. Okay. For example, say topic 2 is subscribed by the consumer 2. That message published to the topic 2 only sent to the consumers. Okay. It is about the publish subscribe communication model. Next is pushful communication model. Just it is a pushful communication model. In between that, one queue is there. A queue, it stores the data, that is published data in a order, it receives to the consumer. Okay. Here in this push-pull communication model, push the data from the publisher, pulled by the consumer through a queue. Okay. Here in this case, push-pull communication model, in which the data push the data to the queue, and consumer pull the data from the queue. Producer do not need to aware of consumer. Producer, that is a push data, is not aware of the consumer. Only who are aware, the queue will knows that who are the consumers. Queue helps in decoupling the message between the producer and the consumer. It also acts as a buffer. It acts as a storing element buffer, which helps into the situation where there is a mismatch between the rate at which the producer pushes the data and the rate at which the consumer pulls the data. This pull queue, it acts as a buffer. It has a buffer in between the publisher. Publisher push the data into the queue. Queue is a storage element. Queue is a just buffer. Whenever a pushing rate and pulling rate are not matches, that data is in the buffer. From the buffer, it can be dragged. That is for the synchronization purpose. A queue will going to use us. Next is exclusive pair communication model. Next is exclusive pair communication model. In the exclusive pair communication model is a bidirectional full duplex communication model that uses the pre-registered connection between the client and server. Previous three models, only server sends the data that the client can receive. Client cannot access of the server. It is a half duplex, only one way that only request the data, it gathers the data, but it cannot send the data to the server. That in the previous three models, it cannot have a bidirectional. In the exclusive pair, it is a bidirectional full duplex communication model that uses the connection between the client and server. Once a condition is set up, it remains open until the client sends a request to close the connection. Once first set up the connection till the client want to close the connection. Client and server can send a message to each other after connection setup. Exclusive pair is a stateful communication model, and the server is aware of all the open connection. It is over the exclusive communication model. The exclusive communication model, first client sends a request to the setup connection. Then server respond to accepting the current request. Once it has been accepted, message from client to server, message from server to client. Okay. Just a wait. Okay. Request to set up connection, response to acceptance from the request, message from the client to server, and server to client. Once the client wants to close, here there is a send a signal from the client. It has to close a request. Once it has been responded, there is a connection disconnect. Okay, it is about the exclusive pair communication model. There are 4 communication models. This is one important question for examination point of view. IoT communication models. There are 4 communication models: request response, publish subscribe, push pull, exclusive pair. These are the 4 different communication models. Next, we'll go for here. Just remember that what is API? API is the application program or programming interface. API is the application program interface. In the IoT communication API, application program interface, there are the 2 basic things. One is called the REST, basic communication API. Second is WebSocket based communication API, application program interface. We'll go for what is these 2 things. I think probably I have a minute side. We'll finish these 2 topics. One is called first REST based communication application program interface. What is the REST? REST is a representational state transfer. REST is the representational state transfer. Is a set of architectural principles by which you can design web service and web application program interface that focus on a system's resources and how the system resource states are addressed and transferred. This is basically a set of architectural principles by which you can design a web service and web applications that focus on the system resources and how system resource states are addressed and transferred. Okay, here REST APIs follows the request response communication model. REST, it follows the request response communication model. Okay, request is from the client, respond from the server. Okay, next REST architectural constraint applied to the component, connectors, and data elements within distributed hypermedia system. Okay, here it is an architectural constraints. Client server, the principle behind the client server constraints is the separation of the concern. Stateless. Stateless means each request from the client to server must contain all the information necessary to understand the request. The session state is kept entirely on the client. Cacheable, that is cache constraint requires that the data within the response to request is explicit, labeled as a cache label or non-cache. So we'll discuss probably in the next class these things. Layered system, uniform interface, code on demand. This is a basic communication model for the REST application program interface. That is HTTP client, HTTP packet, HTTP server. In between that, HTTP, that is REST, awaits a client's HTTP client, sends a through the get the data, put the data, post, delete. These are the HTTP packets. Reset, reload, that is XML or the JSON. That is authentication. Authentication is through the that is server only, RESTful web server. That is resource is the that is URI, represent that the different data are available. From that URI data will gather the data to the server, it sends to the client. We'll go in detail to that in the next class, how to request, what data has to request. That is, a request is get, put, update, delete with a payload using these two, the XML or the JSON, respond through the JSON or the XML. And once it is get the request, get, put data, from that respond to the these things, request server, that simply client and server, that is request respond model only. WebSocket based communication model. WebSocket based communication model allows a bidirectional full duplex communication between the client and server. That is, it is in the previous one. Rest, it is not the bidirectional, it is an unidirectional. It follows the exclusive pair communication model. Follows the exclusive, that rest follows the request response model. That WebSocket follows the exclusive pair communication because it is a bidirectional. Okay, WebSocket app reduces the network traffic and latency, as there is no overhead for the connection setup and the termination request for the each message. The previous case, each message has to send a request and we have to make a termination. In this case, once connection has been established, no need to make any further connection between the client and server. Once you have established a connection, overhead for the connection setup and termination request for each message. Okay, that is the WebSocket. Okay, next class we will discuss about the IoT enabled technology, embedded system, wireless sensor network, communication protocol, cloud computing, big data analytics. By next class we will finish the first model Monday. Tuesday I will go wind up the second model, and on Wednesday probably third model will wind up. 3 days we will take the continued classes. If you have any doubts, any queries, you can ask.